Welcome to the third installment of our videos on linear relations, linear plots, linear equations. This video is going to be about slope, how to find slope from a graph, how to find slope from a couple of points, and the real-world everyday meaning of slope. So when you think of slope, you probably think of how steep something is, and that's exactly what it means. So in a math class, when you draw a graph of a line, you can have a line going. You can talk about a very steep line or a very gentle line, so the slope could be any kind of different values in there, or it might even be sloping downward and be negative slope. So the symbol that we're going to use in all the equations is m. I'm actually not sure why they use m for slope instead of s, but that's what it is in all of our books, and so that's what we're going to go with. So what I like to think about when I think of slope is a staircase. When you have a staircase, there's a certain distance that you have to go up each time you move forward a certain amount. So the amount you go up is typically called the rise, and the amount you go over is typically called the run. And so the slope is the relationship between the rise and the run, how much you go up versus how much you go over. So you can imagine a staircase like this is a lot different than a staircase like this. And likewise, that would be a lot different than a staircase, for example, like this. So this one is much steeper. It has more rise per run. This one is more gently sloped or shallow sloped. It has a very little rise and a long run. Little rise, long run. And this one is kind of in the middle, roughly equal rise and run. So the relationship between how much you go up and how much you go over is going to yield the numerical values for the slope. But we'll be saying rise over run and up and down, left and right quite a bit when referring to the slope. Okay? The slope of the line is exactly equal to the rule for the sequences. So remember, before this we were learning about linear sequences, and we had a starting value and a rule. The rule told you how much to add each time or subtract each time, which told you when you were plotting the points how much to go up or down. Well, the slope is going to be the exact same thing as that rule. So let me just do the same problems we did in the previous video, but with this new kind of mental concept. So start at 3. That means we go up 3 and start here. And the rule is plus 2. So I had said before, go up 2 and make your new dot. Go up 2 and make your new dot. So now we're going to think of this as a rise over run. So we say up 2, and then we say right here, over 1. So our slope, oh, I need an E in there. Our slope is up 2 over 1. So the slope is 2 over 1, which is the ratio between how much you go up and how much you go over. So the ratio is 2, or up 2 over 1, 2 over 1. And then you do it again, 2 over 1. Likewise, you could go backward and down. So you might go backward 1 and down 2. So what about that? What if you go down 2 and you go back 1? Well, down would be negative 2, but backward would be negative 1. And so you get up, when you do that, even if you go backwards, you still get the value of positive 2 for the slope. So this line is kind of looking like that. It has a slope of positive 2. So the rule when you have a sequence is going to give you the same thing as the slope when you have a graph. Okay, let's do this other one. Start at 6. 1, 2, 3, 4, 5, 6. Put your dot. The rule was minus 3. So if we're making a sequence, we'd go 6, 3, 0, negative 3, negative 6, etc. So that's exactly how we plot the points. First we plotted 6, now we're going to plot 3, but we have to move forward each time. Then we plot 0, then we plot negative 3, then we plot negative 6, and you can see that they all line up. So we went down 3 over 1, down 3 over 1, down 3 over 1. So this was negative 3, this was positive 1, then we did it again, negative 3, positive 1, and you just keep going like that forever. So the slope of this line is negative 3. That means we went down 3 each time we went over to the right 1 unit. And when I say over, I always mean to the right, because to the right on the x-axis is positive. So this is the positive x-axis. So we're always talking about going to the right. Okay, so here's the mathematical definition of slope. You should definitely write all this down. We should really write everything down, but in particular, you should write this down. Again, the symbol that we use for slope is m. The word is obviously slope. And I already talked about this concept of rise over run. How much you go up or down by, over how much you go horizontally sideways. Typically it's to the right. But if you go to the left, then it would be a negative run. So you can write the rise, so the rise is on the y-axis. You can write it as this thing called delta y. This symbol delta, it means change in. So delta anything is change in whatever follows it. So delta y is change in y, delta x is change in x, delta elephant is change in elephant, delta happy face is change in happy face. It doesn't matter what follows the delta. The delta itself just means a change in whatever that variable is. So to get the change in the y value, you got to subtract your two values from each other. So if you started at, say, 6 and you ended at 3, you had a difference of 3. If you started here at 4 and you ended at 2, you had a difference of 2. Something like that, just as examples. Okay, so find the slope of each line. Let's see if we can apply this idea of rise over run to a graph. So we can draw what's called a slope triangle. So to get from one point to the next, we can draw a triangle and see how much did we actually go up and how much did we actually go over. But it's really important when you're doing this that you're able to accurately identify the points. So you have to find some points on the graph that are nice whole numbers. And that's not always as easy as it seems. But to me it looks like this one right here goes through this point. Not good, not good. This one is maybe. That one looks pretty good. That one, I guess that one looks pretty good. And that one looks pretty good. So if we think of all of these points, let's look at the rise over run and see if we can figure it out. So to get from here to here, I had to go up this much and then over. So I had to go up 3 and I had to go over 2. So my rise over my run would be up 3 over 2. Well, if this is a straight line, then the rise over run, or the slope, the increment that I go up each time should be the same no matter where I look. So what if I look over here? Here I went up 1, 2, 3, and I went over 1, 2. So again, whether I look over here or I look over here, I get the same slope either way. So if the slope is up 3 over 2, that's the same as up, say, 1.5 over 1. So if I go from this coordinate to this coordinate, I can go up 1.5 over 1. So up 1.5 over 1 is the same as up 3 over 2. It's also the same as, what if I go from here all the way to here? I could go from here all the way up to here and all the way over to here. That would be 9 and 6. Up 9 over 6. So the value that you go up and over isn't important. It's the ratio of how much up divided by how much over that tells you the actual slope or steepness of a line. Okay, let's do a second example. Again, we want to try to find some good points. This one looks good. That one looks like it's probably good. That one looks good. That one looks good. Okay, so here I'm going to go down 1 and then over 3. So down 1 is negative 1 and then over 3. So then down 1 over 3. So negative 1 over 3. So again, my slope, which is my m value, which is my rise over my run, is negative 1 over 3. So my slope here is negative 1/3. Notice this one, which is a negative slope, is sloping kind of downward when you look from left to right. And this one is sloping upward when you look from left to right. Furthermore, this one is pretty gentle slope, and its value is 1/3. Negative meaning downhill, but the numerical value is 1/3. This one is much steeper, and its value is 1.5 or 3/2. So any value bigger than 1 is going to be a steeper line. Any value less than 1, like a fraction, is going to be less of an incline and a more gentle slope. Okay, so another way that we could find slope is, instead of if we're given the entire graph, we can just be given 2 coordinate points. What if we want to find the slope through these 2 coordinate points? So instead of using rise over run, we're going to need to actually plug in the value of these points. So we have to pick one of the point as 0.1, one of the point as 0.2. So we can pick this guy to be 0.1, so we could call him like x1, y1. This guy might be our 0.2, x2, y2, and we can find the slope this way, so I'll just do it right here. y2 minus y1. That's going to be y2, which is 5, minus y1, which is 1, divided by x2, which is negative 2, minus x1, which is 6, and that's going to give me 5 minus 1 is 4, divided by negative 2 minus 6 is negative 8, which I should always reduce, and that's going to be 4 divided by negative 8 will reduce to negative 1/2. So my slope is going to be negative 1/2. And so we should I'm going to try to verify that on the graph. So what if I actually plot these 2 points? Negative 2 comma 5. That's back 2, up 1, 2, 3, 4, 5. And this other point, 6, 1, over 6, 1, 2, 3, 4, 5, 6, up 1. If I actually plot those 2 points, and I imagine drawing a line right through them, if I wanted to find the slope, I could draw a triangle here, and I could see my rise and my run. So this point right here was negative 2, 5, and this point right here was 6, comma 1. To get from here down to here, I had to go down 4, and to get from here all the way over to here, I had to go over 8. So my rise over run is down 4, and then over 8, so down 4, over 8, and that again gives me negative 1/2. So you can plot the points themselves, and then use rise over run on a graph, or you can, instead of plotting and doing it visually, you can just do it mathematically by plugging in the 2 coordinate points in for your x and y values here. It doesn't matter which point you choose to be 0.1 and which point you choose to be 0.2, as long as you're consistent. If I use 6 as my x1, I need to use 1 as my y1. I can't mix which one is x1 and which one is y, like x2. I couldn't use this as my x1, but this as my y1. Like x1 and y1 are a single coordinate point, x2 and y2 are a single coordinate point. Okay, so you've learned how to find the slope knowing 2 points, either mathematically with the equation or graphically by plotting the points and looking at rise and run. You've also learned how to find the slope by drawing a slope triangle onto a graph and looking at rise over run. Positive slopes going uphill, negative slopes going downhill. And there's another way that we can try to do this, or try to visualize this, which is graphing stuff with a given slope. So this says, try to graph a line with a slope of 2. But it doesn't ask us, or doesn't tell us any point or any starting value. So let's just do the easiest one possible. Start here at the origin. If the slope is plus 2, that means up 2 over 1, make a dot, up 2 over 1, make a dot, up 2 over 1, make a dot. And then you could go down 2, back 1, down 2, back 1, down 2, back 1, and we can draw a line. I'll try to draw it straight right through those points. So this line has a slope of 2. And in fact, what's the starting value or y-intercept? The starting value is right there at the origin. So it started at 0. But there's a million other ways that I could draw a line with a slope of 2. I could just pick a different starting value. What if I picked a starting value of like 4? Then from here I could go up 2 over 1, or I could go down 2, back 1, down 2, back 1, down 2, back 1, etc. And then I could draw this line in, which also has a slope of 2. So this one has a slope of 2, but it has a starting value of 4. I could also start way down here and go up 2 over 1, up 2 over 1, up 2 over 1, and I could draw in a line right here. So what do you notice about all these lines? Any line with a slope of 2, it has the same rise over run, and it has the same direction that it's pointing. So the slope really tells you the direction that it's pointing and how steep it is, and then where it's actually located on the graph is given to you by the starting value. So lots of different lines can all have a slope of 2, but they'll have maybe different starting values. Okay. Very last thing is trying to understand and identify the different types of slope. So positive slope means you're going uphill. So this line right here has a positive slope. This line right here has a positive slope. This line right here has a positive slope. Because when you look left to right, they're going uphill. Okay. Negative slope would be downhill, so this line would have a negative slope. This line would have a negative slope. This line would have a negative slope. So you notice it doesn't matter which quadrant they're in, whether they're on the left, the right, the top, the bottom. It only matters what the direction is. So all the ones with negative slope, they go down and over, down and over. Here we go, down and over. All the ones with a positive slope went up and over. So from here we went up and over. Here we went up and over. Here we went up and over. But there's other options. What is a zero slope? If slope is rise over run, that would be 0 would be our rise over some number. So if we don't go up at all, that means we're a horizontal line. So that right there would have a 0 slope. Or, for example, this right here would have a 0 slope, or this right here. So if the slope is 0, then you're not going up or down, you're just flat. And lastly, an undefined slope. What's the one number you can't divide by? So when you're doing your rise over run, if your run is 0, that could be a problem. If you have a number like, say you go 7, 0, that would be up 7 over 0. You can't divide by 0, right? So that means it's undefined. So anytime you would try to divide by 0, that means your run, or the horizontal distance that you would go sideways, is 0. That means the slope is undefined. So if you have a vertical line straight up, this one has a rise, but it has no run, and that would be undefined. So let me give you another example. I'm just drawing them all over the place. Right there is one, vertical, doesn't matter where it is. Any vertical line, so undefined is vertical. You should write this down and memorize it. And this is horizontal. 0 slope is horizontal because the rise is 0. Vertical is undefined because the run is 0 and you cannot divide by 0. Okay, so that's all we have for this kind of concept and definition of slope. You could have a slope positive, negative, horizontal, which is 0, or vertical, which is undefined. You can find the slope given a couple of points. You can find the slope given a graph using a slope triangle. And if you're given the rule, that's the same as the slope. So if you're given a sequence with a certain rule, that's the same as the slope, which is the rise over run. Alrighty, I hope this was informative, and I encourage you to come back and watch the next video.